Good day, everyone. This is Group Pleasant Blake. And I'm yours truly, Meliza o Combate, together with
Fatima Rhyha A. Basa.
Hanishin Pantaha.
and we're here to explain how LEDs, buzzers, and 7-segment displays work and their importance.
In this video, it shows a simple circuit with an LED. Even if it's a simple circuit, we should know the proper sequence in wiring and coding because it's necessary. Proper input and wiring are a must for the circuit to function correctly. This activity shows the LED or LEDs aren't just for turning on and off, they can also have varying light intensity. Like in this setup, the light slowly brightens and dims because of the Arduino Uno. The LEDs take the turns turning on and off. When one LED lights up, the other turns off. With the help of the code, it maintains the alternating sequence between the two LEDs. When the button is pressed, the Arduino detects it and turns the LED on. When the button is released, the LED turns off. When we turn the potentiometer, it changes the LED's brightness because it controls the amount of electric signal energy sent from the Arduino Uno. The main challenges we faced was not about understanding the technical part but more about handling the components and assembling them correctly. We made simple mistakes like connecting the wires in the wrong way, forgetting to plug the circuit into the Arduino Uno, and finding out that some components were not working properly. The biggest lesson we learned was the importance of being careful and checking everything step by step, every wire, connection, and components to make sure the circuit works properly. As you can see, the button controls only two states, on, press, and off, not press. When pressed, it produces a sound from the buzzer. The buzzer can produce different frequencies and durations of sound, allowing it to create a musical melody. This shows how sound can be controlled and used to deliver complex information. In this activity, the buzzer beeps in Morse code for SOS by applying proper timing for dots and dashes. Through this, we understand how buzzers work and realize the importance of Morse code as an emergency communication tool. As you can see, this circuit works like a buzzer alarm that activates when the light level drops. The LDR helps control the buzzer's sound. When there is more light near the LDR, the sound becomes weaker or stops. The potentiometer allows us to adjust the buzzer's sound output. It highlights how we can fine-tune circuits. showing that analog input gives more flexibility compared to simple on or off control. Throughout the lesson, we encountered only a few challenges while completing the activities. In Activity 2, the button did not work at first because the wire was not properly connected to the button's leg. And in Activity 3, the buzzer failed to produce a melody sound during our first two attempts. These challenges taught us that the importance of checking connection carefully and being patient in troubleshooting until everything functioned correctly. Our first activity is displaying a single digit. In the first activity, we chose to display the number 3. If we light up the right combination of the segment, we can show the number 3. This shows us how we can use the display to represent the numbers clearly. Activity 2. Displaying numbers 0 to 9 sequentially. We can make the 7 segment count from 0 to 9 one by one. It goes 0, 1, 2, 3 and so on until 9. This looks very similar to how numbers appear on calculators, clocks, or digital devices we use every day. We face several challenges, such as wrong wiring connections, placing the display in the wrong orientation on the breadboard, coding errors, and even issues with the damaged wires and resistor. This mistake caused the circuit to malfunctions and delayed our progress. However, from these difficulties, we learned the important lessons. We realized the value of double-checking our wiring, making sure the display is placed correctly, and being accurate and patient with our coding. We also learned the importance of testing components first to avoid problems. Overall, this experience taught us to be more careful, patient, and resourceful in solving errors, which will help us in future activities. We made the dancing LED work by connecting multiple LEDs to a microcontrol center or circuit. We programmed it to turn the LEDs on and off in a specific order. This created a moving light pattern that looked like the LEDs were dancing. We made the 7-segment display show custom letters by programming each segment to light up in specific patterns. Each pattern formed a different letter like A, B, C, F, and E. The program then cycled through these patterns one by one, creating a looping display of letters. In our task, we encountered different challenges, such as putting the wrong value in the code. For example, writing 3 instead of 2, which led to incorrect outputs. We also had wiring errors on the breadboard, making the 7-segment display fail to show the right number. Another issue was dealing with the damaged resistor, which affected the flow of electricity and caused the circuit to malfunction. This mistake made the activity more challenging and required extra time to fix. From these challenges, we learned the importance of teamwork and communication. We realized that the careful discussing and reviewing our work with one another helps in spotting mistake more quickly. We also learned problem-solving strategies, such as testing one part of a circuit at a time, instead of checking everything all at once, which made troubleshooting easier. Lastly, we learned the value of resilience, that even when mistakes happen, we should not give up but instead see them as opportunities to improve. This lesson will help us to become more confident and capable in handling similar activities in the future. Looking back at our activities from Lesson 1 to Lesson 3, we can see how each task gave us both challenging and valuable learning experience. In Lesson 1 with the LED, we struggled with simple wiring at first, but we learned how important precision is in connecting circuits. Lesson 2 with the buzzer taught us how sounds can be controlled through coding, wiring, and although we encountered errors, we realized the importance of following instruction carefully and testing step by step. Lesson 3, which involved the 7-segment display, was the most challenging since we need to combine coding, correct wiring, and proper component placement tasks, such as a dancing LED and display the number 5 on the 7-segment display that turns off in a loop, really tested our patience and attention to detail. especially when dealing with coding errors, wrong wiring, and faulty components. Through these challenges, our perspective has changed. At first, we thought these activities were just simple outputs, but we came to understand that every error is part of the learning process. We proved to ourselves that mistakes are not failures, but opportunities to grow and improve our problem-solving skills. We also learned the value of patience, teamwork, and careful observation, which are not only useful in electronics but also in real-life situations. Overall, this lesson showed us that with effort and perseverance, even difficult tasks can be accomplished successfully. Looking ahead to Robotics 2, we are inspired by the challenges and lessons we have already faced and conquered in Robotics 1. What once seemed difficult has taught us patience, teamwork, and determination. And these qualities will guide us as we move forward more advanced projects. We are excited to discover new possibilities, to apply our creativity, and to push ourselves beyond our limits. With the foundation we have built, we are ready to embrace Robotics 2 not only as another subject but as an opportunity to grow, innovate, and achieve more than we thought possible.